Okay, part B to this question, it says find the nearest minute the time that the balloons are closest together. Okay, so we've established they don't collide, so when are they actually closest together? So what we could do here is a little vector diagram really. We think about A here and our B here. Of course we've got vectors, we've always got the position vector relative to the origin, so we'll look at that there, okay, in terms of A and B, and we've got our origin here, okay. Now along this line here is a position vector RA because it takes you to A, and along this line here you've got position vector RB because it takes you to B. Now if we were interested in working out the distance from A to B, okay, because that's what it's saying, isn't it? It says when find the time when they're closest together. So to get when they're closest together, we need the distance between them. We need to work out what that distance is, okay, or certainly the time. We're interested in when the distance here is at its shortest. In other words, when AB is at its shortest. Okay, so if we think about AB, right, think of it as a vector, A to B, right. Now to get A to B, vector form, going from A to B, you'd have to go A to O and then O to B. Okay, so A to O and then O to B. So it would be AO plus OB. Yeah? And of course A to O is sort of like going the opposite way to RA. Opposite way, so that would equal minus RA. Think about it, because you're going the opposite way, plus then RB. Okay? So that essentially equals to RB take away RA. Right? So if we work that out there, here I'll just start on the left hand side here, quite close to it. We'll work out AB by doing this, RB take away RA. So I need to go back to find out what my RA was equal to. So I've got them here, and my RB was equal to. So my RB down here. So I've got 3t plus 1i plus 2t minus 5j plus minus 5t minus 1k. And I want to take away then my RA, which is here, so take away 2t plus 3i, take away minus 2t plus 4j, take away minus 3t minus 5k. Okay, so I've got all this from up here, okay, from what I did in part A. So then what I do then is I simplify this then, okay, put the i's together, right? If you think about it here, you've got that I there and you've got this I here, and we're taking them away. So 3t take away 2t is t. 1 take away 3 is minus 2. Okay? Do the same then with the j's. 2t take away, because we've taken away, don't forget. So 2t take away minus 2t. Well, 2 minuses make a plus, so you get 4t there. Minus 5 take away 4 is minus 9. J. And then you've got the k's then, so you've got minus 5t, and then you've got to take away minus 3t, so 2 minuses make a plus, so that would be minus 2t, and then minus 1k, and then again you've got 2 negatives, so that would be plus 5, or take you plus 4 then, okay, when you work that out. Now, we're interested, as I said, in the distance AB, okay, and we want when the distance at its is least, isn't it? When the distance at its least is when they're closest together. So to get the distance, okay, we need to find the size of this, don't we? So we need to take the modulus of it to get the actual size of it. Alright? So we take the mod of it, okay? Here, I don't need that line underneath there, because I've got an arrow there. But I take the mod of it, so to get the actual size, we'll give you the distance. Remember, they're the same magnitude of it, which is the same as finding the distance. Magnitude and distance are the same thing, right? So you look at the size then by squaring each term. Okay, the i's and j's disappear then, because you're timesing that by itself, so the i's go. Okay, so you've got all this in here to square. There's a lot of work, okay? But we'll see what we get to now. So you've got square root. Now, if you've got this here, you've got a bracket, you've got to FOIL it. So you get t squared minus 4t plus 4. This bracket then squared, you get 16t squared minus 72t plus 81. And then this bracket squared, plus 4t squared minus 16t, okay, plus 16. Alright, so I've foiled 3 brackets there. This then becomes t squared, 16t squared plus 4t squared is 21t squared, minus 4t minus 72t minus 16t is minus 92. Is that right? I think it's minus 92, is it? Yeah, I think so. And then you've got the constants then, 4 and 81 is 85, plus 16 is 101. Okay, so you've got that there. So AB, size of it now, okay, the actual distance is this, right? Now, we want the distance when it's at its minimum, okay, right? Now, if you think about it, we want this at its least, okay? Now, think about how you get things at its least. Of course, if you think back to stationary points, to get the least value in the curve, you've got to do dy dx, haven't you? And then you've set it to equal 0, like when the gradient 0. Okay, so it's all about where the gradient is 0 and you get the least then. So we do the same here. We could say, if we differentiated this, we could get the least distance from that, right? Now, before we differentiate, what we're better off doing actually is squaring both sides, because it works out a lot better. We're allowed to do that. So you've got AB squared, okay, you can get rid of that then, just AB squared, and square this side, you get 21t squared minus 92t plus 101, okay? So you're allowed to do that, because if you're looking for the least of this, it's the same as looking for the least of AB squared. It's exactly the same. So to get the least, we need to differentiate this, don't we, and set it to 0. So we can say for closest together, you can say this, the closest together when AB is least, okay, which is the same as, which implies AB squared is least, okay, so i.e. this occurs using what we learned at C1 when d by dt of AB squared is equal to 0. So d by dt 21t squared minus 92t plus 101, okay, equals 0. So if we do d by dt of this, you get 42t minus 92 equals 0, and then you can get your answer from there then. T will equal 92 divided by 42. Okay, so you get 2.19. Okay, and 2.19, and that's our answer, 2.19 hours in this case. And we've got our answer.